So, good morning to all. So, let us start the today's first class. So, welcome to this class of electrical machine first. I will be taking this class and we will be studying the different topics. So, first of all, I would like to share the syllabus with you that what is the syllabus of our this electrical machine first chapter. So I think so the screen is visible to you and you can see that we have a course named as electrical machine first, and the code of this course is E246. And what is its outcome of this course? That you will have a proficiency in electrical machine and its related applications. Moreover, you will also study about the constructional feature, the working, the testing, and certain operational issues related to the one of the basic static machine called transformer. Then another unit that will be related to this, which will come as a course outcome, that you will also come to know about the DC machine constructional feature, working, types, starters, and how to control its speed. And lastly, you will also come to know about the cross field machinery and their application. So these are the four outcomes of this course, electrical machine first. And as you can see that in the unit 1, we have a transformer as well as the auto transformer. Okay. Then in the unit 2nd, we have two topics. One is the polyphase transformer. Another is the electromechanical energy conversion principle. Now this electromechanical energy conversion principle will be used, the basic concept studied in this topic will be used in our unit 3rd, where we will study about the DC machine. Then the last unit is related to the DC motors, okay, the unit 4th. And we have a different test. We have not only have constructional features, working principle, but different types of tests to be conducted on either transformer or on DC machines, which includes our DC generator as well as DC motors. So I think so this syllabus is with all of you, and now you can go through this syllabus that what you have to read. Now, first of all, what a machine is. Today I will discuss with you the very basic concepts which will help in understanding this topic of electrical machine. So what an electrical machine is there? In layman language, electrical machine simply means which a non-living device which helps the human being so that its time and energy is being saved. This is the general meaning of a machine. Okay, now you have a different type of machine in your home, in your office, in your college, in your market. Okay, everywhere there is a machine is there. And in fact, I can say confidently that without the electrical machine, you cannot spend a single second at any location at any instant. Everywhere there a machine is there. I am here in this room where I am taking your online class. Here also you can see that I have a this computer is also a machine. I have a photostat machine. I have a UPS. I have a fan. I have a a digital clock, I have a tube light, and these all are parts of the machine. These are all are in fact machine, small machine which are helping us, which are aiding us. Okay, and these are all being powered by so-called our electrical energy. Okay, so in fact there are two types of machines are there, electrical machines. Now since they are being powered by electrical energy, by electrical power, okay, therefore they are called as electrical machine. Okay, so as far as the classification is concerned, in general we have two types of machine, static machine and the rotating machine. Okay, now a static machine means one which is stationary in nature, because whenever we talk about machine, something rotation comes in our mind, but machine does not mean rotation. Machine can be static and can be rotating also. So the generalized classification of machine is that these are static machine and rotating machine. Among the static machine is the one of the most versatile device, that is called a transformer. The transformer is the device which is being frequently used in most of the electrical system, whether it's a transmission system, whether it's a generation system, or whether it's a distribution system. Transformer is an integral part. जो ट्रांसफॉर्मर है ये ऐसा इंटीग्रल पार्ट है जो इलेक्ट्रिकल के हर सिस्टम में यूज होता है, चाहे वो मैकेनिकल, चाहे वो ट्रांसमिशन हो, चाहे वो जनरेशन हो, चाहे वो डिस्ट्रीब्यूशन हो. उसके नाम अलग अलग हो सकते हैं. एक जगह पावर ट्रांसफॉर्मर कहलाता है, एक जगह डिस्ट्रीब्यूशन ट्रांसफॉर्मर कहलाता है, और हमारी लेबोरेटरी में जो यूज होता है उसको हम ऑटो ट्रांसफॉर्मर कहते हैं, मगर इसका यूज सभी जगह है. तो इट इज अ वेरी वर्सेटाइल डिवाइस, एंड you will surprised to know that among all the machines, the transformer has the highest efficiency. Why it is having a highest efficiency? The reason is only that what is that reason? Can you elaborate it? The reason is that it is a static device. There is no motion in it. There is no rotation in it, and that is why there is no wear and tear losses are there, and due to which it is the only machine which has the highest efficiency, and the efficiency ranges from 98% to 100%. 100% is the ideal efficiency, but it is 98, 99 like this. So only losses are very small, 1 or 2% losses are there. And you did not have to go anywhere. Outside your colony, there used to be an transformer installed in the field. That is also a transformer. That is called a distribution transformer. Okay, so by standing at a distant location, you can visualize the different parts. That what are there? Where is primary winding? Where is the secondary winding? Where is the core is there? Okay, how line is coming? Input line is coming. How output line is going? Everything you can see through your naked eyes in the transformer installed in your colony or mohalla. Okay, or in your city. In our college also, in our department also, behind the department there is a distribution transformer is there. In front of the second year hostel there is also a distribution transformer is there. So you need not have to go to any industry to visualize its features, to visualize its parts. It is there in front of you, nearby you, in your colony, in your neighborhood, in your city. So this transformer is an integral part, and as far as it is a 4 hour credit hours are there, where 3 will be your 3 credit hours are your theory related class, and 1 credit hour is related to your practical class. So we will have a machine laboratory also. We have a very good machine laboratory, okay, where we have the experiment related to transformer, 3-phase transformer, single-phase transformer, DC motors, DC generators, induction motor, synchronous generator, and so on. Okay, so it is a very good versatile device, the transformer, and our first unit will be related to our transformer only. Now, as far as the teaching is concerned, I will be dealing sometimes on the classroom on the board, sometimes through PPT, sometimes through some videos. I will also share the PDF material to you. Okay, till we have our online classes. Okay, we will be meeting through online mode. Okay, so my voice, my picture, everything is clear or not? Let me know from your side. Am I audible? My voice is clear. Okay, my voice is clear. Thank you, Adhikari, Arjun Dhakad and all. So now definitely you ask what a transformer is. So let us start today with transformer. Okay, today I will be discussing verbally only. From tomorrow onwards we will be discussing either on the board or through PPT. Okay, so you will ask what a transformer is it clear? Definitely a question arises in your mind, what a transformer is. So can anybody first of all can give me any definition related to transformer, what a transformer is? Hmm. Yes, anybody? Just speak out. Machine that transfers energy. Device can step up or so you are again not giving you uh, Ujjwal, who is giving Sanjay Adhikar, device can step up or down current, alternating current. Machine that, who is that? Pranjal Singh is saying machine that transfer electrical energy from one circuit to another. Uh, so let us first of all I will give you the picture. Okay, how my transformer look like. Okay, so is it visible, this picture? Okay, the same picture you can see uh, in your neighborhood also, in your colony also, in the form of distribution transformer. Okay, so this is the external view of the transformer. Okay, so this is, you can see there are how many bushings you are, these are known as these brown colors, the brown color things are called bushings. Okay, so you can see there are three bushing, the big one, two, three, they are on the one side, then small four bushing, this brown color, one, two, three, four. Yeah, some people are giving good definition. Okay, I agree with you that you are giving a very good definition. So uh, let me somebody says Pranjal Singh transfer this energy increasing or reducing voltage. Okay, alternating current circuit to either increasing or decreasing voltage. A device is transfer electrical energy from alternating circuit to either increasing or reducing voltage. Very good. Aditya Devis transfer electrical energy from an alternating circuit. So many people are giving definition. So I will go to definition. First of all, the picture is very clear. Now why I am calling it to be a distribution transformer? It is a distribution transformer. Can anybody can that how I am looking towards this transformer? I am saying it is a distribution transformer. It can be a power transformer also. Later on, I will tell you difference between power transformer and distribution transformer. But on what basis I am saying that it is a distribution transformer? Can anybody can give answer? By looking to this picture, no, it can, Rohit Gehlot, it can distribute electrical current. Everybody distribute electrical, whether it is a power transformer or distribution transformer. Output are more than, one body is saying, who is saying like this, output, Avinash is saying output are more than input. Output are more than input. Which output? Avinash, can you elaborate it? No doubt you are coming to the point, output are more than input. Yes. No, out points are not 3. In fact, out points are 4 and in points are 3. So now see, you can see I just annotate through annotation. I will tell you. Now this is one input, this is second input, and this is third input. Okay. So the inputs are 3, and since big bushings are there, so this is the high voltage ends. 1, 2, 3. Here you connect the wire. Okay. One is here, another is here, another is there. Therefore you are feeding an input voltage of 11 kilovolt. Okay, 11 kilovolt is being fed here, and these are the 4 output points. One is R phase, another is Y phase, this is B phase, and this is your neutral. So this transformer used to be in your colony, and you used to get single phase supply. Okay, one R and one neutral wire. Okay, similarly other house will get one Y and one neutral point. Some other house will get one B phase and a neutral. In this way, 11 kilovolt is the input here. Okay, and 440 volt 3 phase is the output volt on the these 3 smaller bushings, out of which we are taking a single phase, that is 230 volt approximately we are getting at the home, because in most of the domestic home we have a single phase supply. So is it clear or not? I think so. So what are the other parts that we will deal? This is a conservator tank is there, these are bushings, these are fins for providing coolings. Okay, then oil is also there in this tank, okay, which provide cooling to the windings. Then natural cooling is also being provided with the help of these fins. All this we will learn later on, but now with the help of this picture it is very clear what a transformer looks like. Am I clear? Okay, Avinash, no problem. Input are 3 and output are 4. Whenever this type of transformer you see, you immediately confirm that it is a distribution transformer. Clear? Now come the definition of the transformer. Somebody, Adhikari and Avinash and many people and Aditya Gautam has given some definition. So let me give you the exact definition. Okay, what the exact definition of a transformer is there. Transformer is basically, first of all, is a static device. As I've already told you that when you classify machine, there are 2 types of machines are there. There are many classifications are there, but the generalized classification is that static machine and rotating machine. Among the static machine, the only versatile device which we have is our transformer. And what does this transformer do? That it is first of all is a static device which transfers electrical energy from one circuit to another. Which transfer electrical energy from one circuit to another. Now I am giving a pause here. Whenever we transfer electrical energy from one circuit to another, for one point to another, we transfer with the help of conductors. Everybody agrees or not? Okay, suppose electricity is there in this room and I want to transfer it to my nearby room. What I will do? I will bring 2 wires and just take that wire to that another room, and I will get the electricity in the another room. Do you agree or not? So here the process of transferring electric energy is through conduction process, through conductor. Clear? But in transformer, see the difference. Transformer also transfers the electrical energy, the electrical power from one circuit to another, but not through conduction, but through another process called induction. Okay, so I will give you the exact definition. First of all, I will explain the terms which are coming. So transformer is a static piece of device which transforms electrical power from one circuit to another via magnetic field. Now see, it is not through conduction, but is through magnetic field, keeping the frequency constant at the same frequency. This is a very important point. Okay, that is, transfer of power is there from one circuit to another. Okay, but not through conduction process, via magnetic field. This is a very important point. It is through magnetic field, and This all happens at a particular frequency, and in our India that frequency is 50 hertz. That frequency is 50 hertz. So first characteristics of a transformer, that it is a static device. What is it? Is a static device. That is, there is no rotating part is there. Secondly, it transfers electrical power from one circuit to another. People says that it changes power. Mind it, power cannot be changed because power is derived from energy. You cannot change the energy. You can transform energy, okay, as per the law of conservation of energy. Okay, in fact, ideally, input power is equal to output power. Ideally, input power is equal to output power. You are not changing the power. Power remain constant. No doubt the output power you do not get equal to the input power. Do you know why? आपको इन जनरल आदर्श अवस्था में इनपुट पावर इज इक्वल टू आउटपुट पावर हमेशा रहेगी, लेकिन हमेशा हमें आउटपुट पावर कम क्यों मिलता है? क्या कोई बता सकता है? हमें इसलिए कम मिलता है क्योंकि हमारे बीच में मशीन में कुछ लॉसेस हो जाते हैं, ठीक है। अगर उस लॉसेस को भी जोड़ दे आउटपुट पावर में तो वो किसके बराबर होगा? इनपुट पावर। तो हमें बहुत बड़ी इक्वेशन मिली, क्या मिली? वो मिली कि इनपुट पावर इज इक्वल टू आउटपुट पावर। इनपुट पावर इज इक्वल टू output power, and ideally, but practically, input power is equal to output power plus losses. This is a very important point. Okay, so let me share something. So the first definition, in case of the first characteristics, is that it is a static device. The second characteristics is that it transfers power of one circuit to another, and ideally input power is equal to output power, ideally. But practically what happens? There are some losses in the transformer itself. Therefore, P in is equal to P out, which you get at the terminal end, plus losses. Now this is definition is true for all types of electrical machines. This is true for all type of machines, whether it is a static machine or rotating machine. In fact, this equation P input is equal to P output plus losses is true for all type of machines: synchronous machine, induction machine, DC machine, or transformer. Okay, because all these are based on law of conservation of energy, that energy can neither be created nor be destroyed. So whatever input power you have, you are transferring to the output power. But if you are not getting output power equal to input power, it means there are losses in the system. And our whole objective of a scientist or a researcher is to minimize these losses. Minimize these losses. And transformer is that versatile device which has the minimum losses, approximately 1 or 2%. That is, it has the highest efficiency. Is it clear? So again, I am reiterating the definition. What is the definition? The definition is what? Transformer is a static device which transfers electrical energy or electrical power from one circuit to another via magnetic field. Mind it. Again, I am using the word via magnetic field. This is again a special device which is not transferring through conduction process, but transferring electrical power from one circuit to another via magnetic field. So input power is being taken by magnetic field, and that magnetic field transfer it to the another circuit, and then the current and voltage starts flowing in the another circuit. So via magnetic field at constant frequency, that is at the same frequency. If the input has 50 hertz, then output will also have a 50 hertz. If the input has 100 hertz, the output will also have a 100 hertz. And one important more thing, that the shape also remains same. If input you are getting sinusoidal, output you are also getting a sinusoidal. So shape and the frequency remain same in case of transformer. And ideally power also remains same, that is input power is equal to output power. What changes? The voltage and current level changes. The voltage and the current level changes. This is what about the transformer. Okay, any doubts so far? Any doubts so far regarding the definition of the transformer? So how voltage and current changes? Power remain constant, but voltage and current level changes. This I can again explain you. Definitely it may be a confusion in some people mind that sir, when uh, power remain constant, how voltage and currents are changing. So let me describe this. Now you know that what is power. Power in general in DC circuit, it is V into I. In AC circuit, single phase AC circuit, PVI cos phi. Okay. So let this be P input. So P output will be also something. This is a V1, I1 cos phi 1. So this is V2, I2 cos phi 2. So ideally I say that P input is equal to Pi is equal to P out. Okay. So if I equate these two equations, so what I will get, V1 I1 cos phi 1 is equal to V2 I2 cos phi 2. Okay. So this value should be same, but I can change V, I can increase V and thereby decrease I, or I can decrease V and thereby increase the I2 so that Pi is equal to P out remain same. So that's how the voltage and current changes. So what happens if on the input side, if you increase the voltage, your current will decrease. Okay, because ultimately you have to keep these two constant. So on the output side, if V2 decreases, then I2 will increase. Okay, so that is why you will find that on one side of the transformer, you have an increasing voltage level but lower current. On the other side, you have a decreasing voltage level but higher current. Okay, so you got my point why this happens. Is there any question so far regarding this? Okay, Adhikari, Aditya Gautam, anybody has any question? Just this should be a two-way interaction. Okay, you can mute yourself, you can mute off yourself and can talk with me if you have any question. Now if you have no question, then let's, okay, I will explain how the voltage and current change. Okay, let us explain once again. Now what happens, Adhikari, please listen carefully. I have told you that P input is equal to P output, ideally, huh? Assuming that there are no losses in the system. Okay, this is, say for example, this is your a transformer. On one end I am giving you input and on other end I am taking an output. Okay, so my input and output power remains same. Okay, now what is P input? Vi V1 I1 cos phi 1, V2 I2 cos phi 2. Now let this say the numerical value of this is 50. So this should be also equal to 50. Okay. Clear? Now suppose my voltage is 25, current is 2 and power factor is say 1. So 25 into 2 is 50. Now if I want 50 on the same side, one thing is that you keep 25, 2 and 3, but this is not solve a problem. Then for what purpose this device is there? So let us say, if I say my voltage is 2 volt, definitely, and power factor is say 1 only, definitely this current should be 50 ampere. Okay, so that these two equation remain same. So here what happens? Voltage is high, 25 volt. Here voltage is 2 volt. So what happens? On one circuit I have a high voltage of 25 volt, on the other side I have a low voltage of 2 volt. But what about current? Here I have a 2 ampere, here I have 50 ampere. So on the side where I am having a high voltage, जिस तरफ मेरा high voltage था उधर मुझे low current मिला, और जिस तरफ मेरा हाई करंट था उधर मुझे क्या मिला? लो वोल्टेज. पावर फैक्टर माना कि दोनों का सेम है. तो हमें क्या मालूम पड़ा कि एक साइड जहां हाई वोल्टेज होगा उधर लो करंट होगा, जहां लो वोल्टेज होगा वहां हमें हाई करंट मिलेगा. आई थिंक सो नाउ इट इज क्लियर, और सम मोर डाउट? क्लियर? ओके, सो it is now clear that what is the function of the transformer, that is transforms electrical power from one circuit to another. So two circuits are there, and later on we will call the first circuit as a primary circuit and another circuit as the secondary circuit. Okay, so involvement of two circuits are there, primary circuit and secondary circuit. Transfer of power is there from this primary circuit to secondary circuit. Okay, and important thing is that this does not take place through conduction, but it takes through another special operation called induction. Okay, so transformer is based on principle of mutual induction. As I already told you that this electrical energy transfer is from magnetic field, and how the process through which magnetic field transfers power from one circuit to another or from one conductor to another is called the induction process. It's called induction process. It is not called conduction, but it is called induction process. Okay, so induction is nothing but transferring electrical power. Now power includes both voltage and current, mind it. Transferring electrical power from one conductor to another via magnetic field. It is called the principle of induction. Now here I exclusively use the principle of mutual induction. So what does mutual induction means? That when a current flows through one conductor, then a magnetic field is produced around it. Now this magnetic field will link the other conductor which is adjoining to that first conductor. So let me explain this again. What is this principle of mutual induction? Now let us say there are two conductors are there. Okay, this is a one conductor and this is a second conductor. Clear? Now what happens? Suppose current I is flowing through it. Okay, current I is flowing through it. Now as per Faraday's law, now this current I is again alternating current. Mind it, the mutual induction principle is meant for AC circuits only, not for DC circuits. Okay, no doubt as per Oersted law, Oersted एक साइंटिस्ट हुआ, उसने कहा था कि जब भी कंडक्टर से करंट फ्लो होगा उसके आसपास एक मैग्नेटिक फील्ड प्रोड्यूस होगा. तो अगर इस कंडक्टर में, ये जो पहला वाला कंडक्टर है, इसमें AC हो या DC, एक मैग्नेटिक फील्ड क्रिएट होगा. लेकिन हम इसमें कौन सा बाहर है? AC, क्योंकि हमें यहाँ पर AC, देखिए AC का वेव फॉर्म मींस लेट अस से एग्जांपल साइनोसाइडल कीप्स ऑन चेंजिंग. अगर ये करंट है, वेव फॉर्म है, पहले जीरो हुई, बड़ी, फिर मैक्सिमम हुई, फिर कम हुई, फिर नेगेटिव हुई, फिर जीरो हुई, फिर सॉरी मैक्सिमम नेगेटिव हुई, फिर वापस जीरो हुई. तो इस प्रकार हमें क्या मिल रहा है, चेंजिंग करंट मिल रहा है, और चेंजिंग करंट के कारण चेंजिंग मैग्नेटिक फील्ड होगा. When we have an AC current, what happens is flowing through a conductor, we have a changing magnetic field around it. Changing मतलब which is varying in nature, पल पल बदल रहा है. अगर चेंजिंग करंट होगा तो मैग्नेटिक फील्ड भी चेंजिंग होगा. कुल मिला के वेरिंग करंट, वी आर गेटिंग वेरिंग मैग्नेटिक फील्ड. सो दैट इज व्हाई AC current is flowing through this conductor. We have a magnetic field which is changing in nature. Now, as per the principle of, as per the Faraday's law, whenever a magnetic flux, a changing magnetic flux links another, now this magnetic flux will be like this. So a current is flowing through this conductor, a magnetic field now being AC, therefore a AC magnetic field is produced around it. Now this AC magnetic field will link this second conductor also. This was my first and this is my second. So this magnetic field produced by the first conductor, ये फर्स्ट कंडक्टर के द्वारा जो मैग्नेटिक फील्ड प्रोड्यूस हुआ, ये एक सेकंड कंडक्टर को भी लिंक कर रहा है. और ये कैसे नेचर है इसका, ये चूंकि एसी है तो इस मैग्नेटिक फील्ड का भी नेचर कैसा होगा, एसी. तो चेंजिंग मैग्नेटिक फील्ड इन लिंकिंग द कंडक्टर एंड ड्यू टू विच एन इंड्यूस EMF, which type of EMF? An EMF is produced which is called induced EMF because it has been induced in it, not being conduced, not being conducted, but it has been induced by with the help of this magnetic field. So this is the principle of mutual induction. दोनों के देखो mutual means आपस में लगाव के कारण, दोनों आपस में पास में बैठे हुए थे, एक में करंट फ्लो हुआ एसी, तो इसने एक वेरिंग मैग्नेटिक फील्ड प्रोड्यूस किया और इसने इस कंडक्टर को लिंक किया तो इसमें भी एक ईएमएफ प्रोड्यूस हो गया और ईएमएफ को हमने क्या कहा, इंड्यूस ईएमएफ. वी कॉल दिस ईएमएफ एज एन इंड्यूस ईएमएफ. You got my point? And this principle of production of EMF is called principle of mutual induction. So transformer is based on principle of mutual induction. I think so this concept is clear. So I am giving you the meaning of each and every word which is being used in the transformer. You got my point? Any doubt so far in understanding the principle of mutual induction? So transformer is a static device. Transformer is a static device which transforms electrical power from one circuit to another via magnetic field at same frequency. It is based on the principle of mutual induction. And what is the mutual induction? That when a current flows, when an alternating current flows through a conductor, an induced EMF is produced in the conductor adjoining it. This is the principle of mutual induction. Is it clear? Is there any doubt so far? If you have any doubt, please write in the chat box or you can unmute yourself. Any doubt? Okay, so Adhikari has asked about the principle of mutual induction. Okay, once again. So transformer is first of all is based on principle of mutual induction. What is mutual induction? Now, since word mutual is there, therefore there will be involvement of at least two things. Okay. Two conductors will be involved in it. Okay. So let us draw these two conductor. Let us, this is first conductor and this is second conductor. Okay. Now say a AC current is flowing through this first conductor. Okay. Now you know that whenever a current flows through a conductor, according to our state, a magnetic field is produced. Now since AC is flowing through it, so the magnetic field so produced will be also be of alternating in nature. Will be also of AC in nature. Sorry. Okay, so what happens? So this type of concentric circles magnetic field is produced. Now since it is in adjoining with it, this conductor, the second conductor, this was first one, this was second one. So this magnetic field, since this conductor is in adjoining with this, therefore the varying magnetic field will link this conductor also. And according to the Faraday's law, when a varying magnetic field links a stationary conductor, okay, an EMF is produced, and this EMF is not produced by conduction but by a process called induction. Therefore this EMF is called induced EMF. This is called induced EMF. Okay. So in transformer also the same thing happens. In transformer also same thing happens. We have a two circuit. One is called primary and another is called secondary. So this is primary, say this is primary conductor, and let's say this is secondary conductor. So what happens when you provide an AC supply to this primary circuit? What happens due to the principle of mutual induction, that is through why magnetic field, an induced EMF will be produced in the secondary circuit. Okay, so that's what happened in the transformer. Okay, so transformer is based on principle of mutual induction, where and voltage and current, when the power is being transformed from one circuit to another. Yes, any doubt so far, Adhikari? Still doubt? I can repeat it, no problem. Anybody has any doubt regarding this? I can repeat it. Now Chobisa is asking, sir, in secondary heating process is also a start. What happened? The heating, when heating will start, first of all tell me. Heating process starts in every conductor where current flows. Where current flows, whether it is a primary circuit or a secondary circuit. Okay. But we used to choose such a conductor which has the capability of withstanding that thermal power. Okay. If we choose a low thermal bearing capacity conductor, then it will burn and it will be of no use after a few hours. So always we choose a conductor which can withstand the heat generated in it. And this heating process will start when current will flow. Even if you touch a rheostat, when current flows through a rheostat, you touch it. Don't touch it, but if somehow you touch in a jerky mode, then you will find it is hot. Or even if you will remove all the connection and immediately if you touch the rheostat, you will find that it is heating. It is in a heated form. Why? Because current flows flowing through. Whenever current flows through a resistor, okay, what happens? That it liberates out heat, and that hotness is due to that liberation of heat only. So any doubt so far? So today what happens? We have started this class of electrical machine, and I have given you a glimpse about the transformer And I also told you that you have seen this transformer in and around your colony, in your mohallas, near your hostels, or even your departments. Okay, this is a versatile device, a static device which transform power from one circuit to another via magnetic field. So it is clear that it has two circuits. The first circuit is called primary circuit and second circuit is called secondary circuit. Why they are being named, in fact you can interchange it also, that I will tell you in tomorrow's class. Then I have told you that it is based on principle of mutual induction. So first of all, you have already learnt about the Faraday's law of induction, that whenever a current flows through a conductor, what is Faraday's first law? Whenever there is a relative motion between a conductor and a magnetic field, an induced EMF is produced. Now in this our transformer case, what happened? The conductor is stationary, the secondary conductor is stationary, but the magnetic field being produced by alternating current is varying in nature. It is varying in nature, it is changing in nature. Due to changing of the flux, an induced EMF is produced, that is being governed by Faraday's second law. This induced EMF so produced will be equal to proportional to the rate of change of flux. And the Lange's law will give you the direction. The induced EMF flow in such a direction that it opposes the very cause. That we will see later on. Okay, so all Faraday's laws are there. Now since there is involvement of two conductors is there, one conductor is passing its magnetic field in which the voltage and current is there to the secondary circuit. So this principle is called mutual induction principle. So from now onwards, whenever people will ask you, will say the transformer is based on principle of mutual induction, which state that whenever a varying current flows through one conductor, then induced EMF is produced in the second conductor adjoining to it. Is it clear? So is it clear or not what a transformer is? Okay, what is its definition, on what principle it is based? So tomorrow we will go some more detail about the so-called transformer. Is it clear? So any doubt so far? I can take 2 or 3 minutes more to clear or doubt. Even you can write your any question in the comment section, because this video is being there on YouTube also. You are live on YouTube, so you can share your comments in the form of your doubts, question in the comment section of the YouTube video. I will definitely reply whenever I will get your comment. Any doubt? This teaching learning process should be a two-way. It should not be one way, that is I only speak. You should also interact with me. Okay, you can unmute yourself also, and you can speak on mic also. Okay, you can also use chat box, but chat box should be used in a secondary way. You can speak out also. I give freedom also, that in the live class, online class, you can speak also. You can ask your question also. You need not hesitate. It may be very simple question, or it may be repetitive question. I will never get irritated. I will try to satisfy you and try to answer each and every question till you will not get satisfied. No doubt. So thank you very much for joining today's. Tomorrow we will meet again at 11 o'clock, because this is a recurrent meeting. The same meeting number, same meeting link and same password will be used. Okay, you did not have to worry. Okay, and this video is also available on YouTube, so you can, if you haven't understand anything, you can again watch this video. Thank you very much.